Hello and welcome to the third and final video of the FP2 chapter Inequalities. Starter question here, review something you need to be able to do before you can do this little section. Sketching the graph of equations that involve a modulus. So to do this, you might have been taught in a few different ways, but what I would normally do is start by sketching the graph that's inside, so x squared minus 10, that will have points at 0 and 10. And it would be an x squared graph, so it would just look something like this. And then I would think to myself, the modulus, what that does is anywhere where it's positive leaves it positive, and anywhere where it's negative it puts a negative in front to make it positive. So this bit down here cannot be in the negative part of the y-axis because it doesn't get that far because of the modulus. So what I do is then reflect that in the x-axis. Oh, it's not very symmetrical, it should be the same as that. And make this a broken or dashed line to indicate where it was and where it is not anymore. So there we have in the solid line y is equal to the modulus of x squared minus 10x. And down here in the dashed line, that was x squared minus 10x. And if I really wanted to complete it, what I would do is continue this reflected part down and indicate what that would have been. What that would have been was y is equal to the negative version of this, so minus x squared minus 10x, or minus x squared plus 10x. And I maybe wouldn't require anyone to do all of this bit down here. If you're just sketching this, all you need is this bit here. The reason I'm doing these bits partly is because it will help explain what we do in this video. So you'll see me doing this a lot. It's not necessary, it's just there to help. And this is what we're going to do in this video, because we're going to solve inequalities involving a modulus, and we are going to do it using this method here that we had in the previous video by sketching the graph. So we can apply that method, sketching the graph, to solve inequalities that involve a modulus. However, we need to be careful of how the modulus sign affects the process. I've already talked about one. Some parts of the original graph inside the modulus might be reflected in the x-axis when you apply the modulus sign. But also as we get to the final example, you'll see that some of the points of intersection, and remember from the previous video, we find these because we need to know the values in order to find the solution intervals. So we need to find the points of intersections of two graphs in this method. But when we do that with the modulus, because of them being reflected, some of those might not be valid. And as I said, we'll look at that on the third example. First example, solve this. Now it doesn't specify a method, but I think this is best done with a graph. So what we're going to do is we're going to graph y is equal to x squared minus 10x, and then apply the modulus, and we've already done this in the starter question. We know what this looks like. Something like this, and this is a 10, and this is a 0. Now to graph the other side of the inequality, that's very easy, y is equal to 24, but it is important to know how far up the y-axis that is compared to this point here. Because if I put it above that, then I've got 2 points of intersection, and if I put it here, then I've got 4 points of intersection. I need to know in relation to this whether this is higher or lower than this point. And to find that, I consider the graph y is equal to x squared minus 10x, and the minimum point of this happens when x is equal to 5, and that gives y is equal to minus 25. And of course that is not this point. Remember, this one here inside the modulus has been reflected with the modulus. What that refers to, and why you'll see me drawing these, is this bit down here. The minimum point of that is minus 25. And when it's reflected, that goes up to 25 here. And it happens at 5. So now I know for sure that 24 does cut this graph 4 times. But it does not cut this graph 4 times, because that goes down like this. It cuts twice. So if I try and solve this equals 24, which I'm going to have to do to find these two intersection points, why don't we do that right now? X squared minus 10x equals 24. X squared minus 10x minus 24 equals 0. X, and that's minus 12. X plus 2. So we get x is equal to 12 and x is equal to minus 2. And obviously the 12 is here and the minus 2 is over here. But as I said, we don't get 4 out of that, we only get 2 because this graph, the one that I've used here, is this one. To get these two with the modulus coming into play, it's on this graph here. And that is part of this graph, which is y is equal to minus x squared plus 10x. So I also need to solve this second graph. This one is equal to 24 will give me these 2 points of intersection. So I'm doing 2 sets of solutions. So we've got minus x squared plus 10x equals 24, and that changes it just enough to be different. Minus 10x plus 24. This time we get x minus 6, x minus 4. X is equal to 6 and x is equal to 4. Obviously either side of the 5. So here we've got 6, here we've got 4. And if you did that one first, of course, it wouldn't give you these 2 points. So you need to do both of these, because the modulus here is kind of combining two different graphs, the positive version of that expression and the negative version of that expression. So we've got our 4 points. The interval, let's go back to the inequality. What were we actually trying to find? When is this graph, the blue graph, less than the red graph? It is less than the red graph in this interval here, from minus 2 to 4, and in this interval here, 6 to 12. And there we go. Second example requires us to do a little bit of rearranging, because we don't really want this modulus 2x and the plus x together. That's going to be really awkward to draw. So this obviously is the same as this, but it's now much easier because the modulus is by itself. 3 minus x is quite easy to sketch as well. So 3 minus x will look something like this. And 2x would look something like this. But what we want is modulus 2x. So all of the negative part changes to a positive. So what we get is this. And it's very important when you're drawing to realize when something is going to intersect. If I hadn't quite drawn this red one long enough, I would need to have realized that they would intersect at some point, because this one has a steeper gradient than this one. And of course that is part of what would have been a y equals minus 2x graph. And they combine in the solid bit here to give the graph we want, which is the modulus of 2x. We have 2 points of intersection, this one using the y equals 2x, and this one using y equals minus 2x. So when we're trying to solve modulus 2x is equal to 3 minus x, we're taking 2 bits. We're taking when this is positive and when this is negative. Solving both of these as before, this is quite an easy one. X is equal to 1, that must be the positive one here. And here we get minus x is equal to 3 minus 3. And that must be this one here. So our two results, we've got minus 3 from the negative version and plus 1 from the positive version. And the question is, when is this modulus graph in blue less than or equal to the graph in red? And it is less than that graph between the two values in this interval here. So from -3 to 1. And here again, our two reflected parts have not had much effect on the question, but in this final example, we'll see that they do. Here we've got find all the values of x such that the modulus of x squared minus 19 is less than or equal to 5x minus 1. So let's start by drawing those graphs. 5x minus 1, that's a nice easy one, nice straight line, comes down quite steep like this, where this is a 1 and this is a 5, minus 5. Now we need x squared minus 19 in the modulus, and again to do that I'll start with x squared minus 19 without the modulus, and that I know goes down to a minus 19, and it's symmetric about the y-axis. So we'll do something like that. My graph at the top there is not very good, but I've curved it in again to be careful to note that it does cross here. Now that's not the actual graph because we need to modulus this, which means the bit down the bottom is not really there. So this bit is going to reflect up onto the other side like this. That will cross at 19. And what I'm going to do is again add on these little bits here to indicate that that would have been minus x squared plus 19, whereas this part of the graph over here is x squared minus 19. And the reason I'm doing that is because when I continue this down here, if I continue the red one as well, there's another point of intersection there. So we've got one there, one there, one there, and one here. But only two of these are actually intersecting with the modulus of this. The reason I'm sketching all four is because when we go to solve this equals this, when we do the positive version, we're going to find this solution and this solution, which is valid for x squared minus 19, but not for the modulus of x squared minus 19. And then when we do the negative version, we'll find this solution, and we're going to find this solution, which is valid for y equals minus x squared plus 19, which we need to get this one, but isn't valid for the modulus of this. So you need to be careful to note that sometimes your solutions will not be valid, even though you will get them as part of your algebra. For x squared minus 19 in modulus equals 5x minus 5 in order to find those points of intersection, and this will go into x squared minus 19, but it will also have to be considered as minus x squared plus 19 in order to find this one here. And we're solving both of these equal 5x minus 5. So over here we've got x squared minus 5x minus 14, which can factorize into x minus 7, x plus 2, and gives us the solution here of 7, and here minus 2. And then solving the negative version of that modulus, we get x squared plus 5x minus 24. And that will factorize. To give us the two answers, minus 8 and 3, corresponding to this one and this one here. So our two valid answers are this one and this one. And the two answers that we got as part of the process, which you might think were valid if you hadn't considered the graph closely, were this one and this one. Going back to the question then, when is the blue graph lower than or less than the red graph? That happens just in this little section here, in between these two values, 3 and 7. So in this small region between 3 and 7, this is true. And there we have our final example, with some valid and some invalid answers coming up, showing the value of a well-sketched graph. These ideas you can practice in exercise 1C, and you can do all of this chapter in the chapter review exercise. And maybe I'll see you for chapter 2.